Somewhere in the ocean right now, hundreds of meters below the surface, a steel tube glides silently through total darkness. It is as long as 2 football fields. Inside it, more than 100 people are living and working. They are cut off from the sun. They are cut off from fresh air. They are cut off from the entire world above them. And they can stay down there for months at a time. Think about what that really requires. There are no windows to open. There is no fresh air to breathe. There are no trips to the surface for supplies. So how does a submarine keep its crew alive and breathing in a place where humans were never meant to survive? It is one of the most incredible survival systems ever built. And by the end of this video, you will understand exactly how it works. Before a submarine can survive underwater, it has to solve one basic problem. It has to sink on purpose, and then it has to rise again whenever it wants. The secret is something called ballast tanks. These are large, empty spaces built into the submarine's hull. When the crew wants to dive, they flood these tanks with seawater. The extra weight makes the submarine heavier than the water around it, and slowly it begins to sink. To come back up, they simply do the opposite. Compressed air is blown into the tanks. That air pushes the water back out. Now the submarine is lighter again, and it floats back toward the surface. By balancing water and air, the crew can make the submarine hover at any depth they choose. It hangs there, perfectly suspended in the middle of the ocean. This balance is called neutral buoyancy, and getting it right is the foundation of everything else. But it is more delicate than it sounds. As a submarine goes deeper, the water pressure squeezes the hull. The temperature changes. Even the saltiness of the water changes how heavy the submarine feels. So the crew is always making tiny adjustments. A submarine hovering at depth is not just sitting there. It is being carefully held in place, moment by moment. Once a submarine can control its depth, the real survival challenges begin. The most urgent problem is air. A large crew breathes an enormous amount of oxygen every single day. There is no window to crack open, and surfacing all the time would ruin the whole point of hiding beneath the sea. So the submarine has to make its own oxygen from scratch. The main trick is a process called electrolysis. The submarine takes ordinary seawater. Then it runs a powerful electric current through it. That current splits the water apart into 2 ingredients, oxygen and hydrogen. The oxygen is released into the submarine, so the crew can breathe. The leftover hydrogen is safely pumped back out into the sea. In effect, the submarine turns the ocean itself into a never-ending supply of fresh air. And this has to happen without ever stopping. A single crew can need thousands of liters of oxygen every day. If the machine ever paused for too long, the air inside would slowly run out. So these systems are watched around the clock. Sensors and alarms constantly measure how much oxygen is in the air. And just in case, there are backups. Submarines carry special canisters, sometimes called oxygen candles. These release breathable air through a chemical reaction. If the main system ever fails, they can keep the crew alive until it is fixed. But making oxygen is only half the battle. Every time the crew breathes out, they release carbon dioxide. In a sealed steel tube, that gas has nowhere to go. And if carbon dioxide builds up, it becomes poisonous. It can harm the crew long before the oxygen ever runs out. So submarines use machines called scrubbers. These pull the air through special chemicals. The chemicals grab onto the carbon dioxide and lock it away. Then the cleaned air is sent back through the submarine. Other filters remove moisture, odors, and harmful particles. The result is a sealed world where the air is renewed over and over, 24 hours a day. Air is not the only thing the crew needs. They also need fresh water. They need it for drinking, for cooking, and for the equipment. But the ocean is full of salt water, which humans cannot drink. So the submarine makes its own fresh water too. It uses machines that remove the salt from seawater. Some boil the water into steam, then collect the pure water that condenses. The salt is left behind. Others push seawater through incredibly fine filters. These block the salt,
but let the water through. Either way, the submarine can make thousands of liters of clean water from the sea around it. And that water does more than keep the crew hydrated. It cools the machines.
It is used for cooking and cleaning. On a nuclear submarine, clean water is even part of the reactor itself. Fresh water is so valuable that the crew must be careful with every drop. They take short showers and reuse water wherever they can. Once again, the ocean around the crew becomes the very thing that keeps them alive. Making oxygen, scrubbing carbon dioxide, purifying water, all of this takes an enormous amount of energy. And this is where modern submarines hide their greatest secret, the nuclear reactor. At the heart of the submarine, a small reactor generates intense heat. That heat boils water into steam. The steam spins powerful turbines, and those turbines do two jobs at once. They turn the propeller that drives the submarine forward, and they generate the electricity that powers everything on board. The incredible part is how little fuel this takes. A nuclear submarine can run for years without refueling. It does not need air to burn fuel like a normal engine, so it can stay underwater almost forever. In fact, the real limit is not the fuel or the power. It is how much food the crew can carry. That is why when a submarine leaves port, every spare corner is packed with food. Crates are stacked in the walkways. The crew literally walk on top of canned goods until they have eaten their way down to the floor. The mission length is not decided by the machine. It is decided by the last meal on board. And the reactor gives the crew one more thing that is easy to forget. Silence. A nuclear submarine does not run a loud diesel engine. It does not come up for air. It can move through the deep almost without a sound. And that is exactly what makes it so hard to find. But there is one more problem we have not solved. Deep underwater, there is no light to see by. And unlike an airplane, a submarine cannot use radio or GPS. Those signals simply cannot reach through hundreds of meters of ocean. So how does a submarine know where it is? Part of the answer is sonar. The submarine listens to the ocean around it. It can send out or detect sound waves that bounce off objects, the seabed, and other vessels. Sound travels incredibly well through water, so a submarine effectively sees its surroundings with its ears. To know its exact position, the submarine uses inertial navigation. Sensitive instruments track every tiny movement, every turn, every acceleration. It all starts from a known point. By adding up all that motion, the submarine always knows where it is. It never needs a signal from the outside world. It is a bit like closing your eyes and walking across a room you know well. If you remember every step and every turn, you can still find the door in the dark. The submarine does the same thing, but with incredible precision. Put all of these systems together, and something remarkable becomes possible. An entire community living for months in a sealed metal tube beneath the sea. The crew live by the clock, not the sun. They work in shifts, day and night. They keep the reactor running, the air clean, and the submarine on course. Every system watches over the people, and the people watch over every system. A submarine, in the end, is not just a vehicle. It is a tiny artificial world. It makes its own air. It makes its own water. It makes its own power. And it carries human life through a place as hostile as outer space. So the next time you picture a submarine hidden somewhere in the deep, remember what is really happening inside. Every breath, every glass of water, every mile traveled, all of it comes from a system that quietly turns the ocean into everything the crew needs to survive. And here is a thought to leave you with. A submarine survives underwater almost exactly the way a spacecraft survives in orbit. It makes its own air, water, and power in a place that should be impossible. So how does the International Space Station keep astronauts alive in the vacuum of space? That is the next video on system logic. If you learned something new today, subscribe, because the world is full of invisible systems, and we are just getting started.